Hi, third grade. I hope everybody had a wonderful Thanksgiving break. I hope you're all relaxed and refreshed, and you've been able to spend some time with your family, and you've been able to really pay attention to those things that you're grateful for and that you're thankful for. And I hope you're ready to begin our next couple of weeks before our Christmas break, ready and raring to go, so that way we can get a lot of work done in the next few weeks, because I know that you guys will do a great job doing it. So I need you to get your math out. We're going to be on Module 4, Lesson 2, and it starts on page 87. So I'm going to have you have all of that out and ready to go with a pencil, and I'm going to get my camera ready to record teaching the lesson. All right, let's go. Okay, so today we are going to be, oops, sorry, my camera's still a little wonky. All right, we're going to be doing Module 4, Lesson 2, and it starts on page 87, and we are going to be understanding the distributive property. So after this lesson, you'll be able to understand and know how to use the distributive property to decompose factors as a strategy to multiply one-digit numbers. So all it means is we're going to be taking the numbers that we're going to be multiplying together, and we're going to be decomposing them, meaning we're going to be breaking some of them apart to get to an easier multiplication problem for us to solve. Something that to get us to a problem that we already know, or one that we can solve more easily. So let's spark our learning with Taj. And Taj is drawing a map of the blocks in his town. There are 4 rows with 5 blocks in each row. What is the total number of blocks? So when I look back at this question, he's drawing a map. There are 4 rows with 5 blocks in each row. What is the total number of blocks? That's what we are looking for. So we're going to be using arrays and facts that we know to show 2 different ways to find the total number of blocks. Well, we can see that the blocks in his town look just like an array, right? We can see we've got rows, and then we've got numbers in each row. So here, they already told us in the problem there are 4 rows, right? 1, 2, 3, 4. So we could make a multiplication problem out of this, right? If I have 4 rows, I would be multiplying it by how many are in each row. And they already told us in the problem, right? There are 5 blocks in each row. 1, 2, 3, 4, 5 blocks in each row. So if I do 4 times 5, I could either count all the blocks, right? Or I could count by 5s 4 times. 5, 10, 15, 20, right? Counting by 5s 4 times. 5, 10, 15, 20. Or if I counted all those up, I would get 20. So there are 20 blocks in his town. Now another way we could solve this is we could break it up. Say I'm unsure how to count by 5s 4 times. I could make it so I could get to numbers that are easier for me to solve. So if I look at my array here, remember when we were doing the area of odd shapes, like shapes that weren't in a perfect rectangle or a perfect square, we would break them up, right? We would draw either a horizontal or a vertical line. So I could do that same thing here. I could draw a vertical line right here. Sorry, my line wasn't very straight. And if I draw a vertical line here, I'm going to create 2 different multiplication problems. Now, both multiplication problems are going to have 4 rows. See, so this is going to be one of my multiplication problems, and this side will be the other multiplication problem. So on the left side, I have 1, 2, 3, 4 rows times 1, 2, 3 blocks. 4 times 3 equals, so if I count by 4s 3 times, or I could count by 3s 4 times. So I've got 3, 6, 9, 12. And then my other problem over here 1, 2, 3, I have 4 blocks, times, or 4 rows, I mean, times our 2 blocks. 4 times 2 is, well, 4, 8, right? 4, 8. Then I'm going to combine my 2 answers. When I add 12 plus 8, I get 20. So there are 20 blocks. I got the same answer, and this one, because 5s are fairly easy for us to count by, it kind of just helps you demonstrate it. But once we get to harder numbers or higher numbers that might be a little more difficult to count by, you're going to see how this strategy is going to be very beneficial, very helpful to you. Okay? So let's go to page 88, and we're going to see where it's going to start really helping us a lot. So we have a map of Nell's neighborhood now. And she's got 6 rows with 8 blocks in each row. How many blocks are there? How could you use an array to help solve the problem? Well, first of all, we have an array right here, right? We've got a nice big array right here. And it wants us to first draw a horizontal line to break apart the array into 2 smaller arrays for facts that we know. Well, how many rows do we have? 1, 2, 3, 4, 5, 6. What's something that we might be able to do fairly easily? What if I do it right in half? A horizontal line goes like this, and what if I break it right in half? How many blocks are going to be in each smaller array? Well, look at, I have 1, 2, 3 rows, 1, 2, 3 rows. These are going to have the exact same number of blocks. Won't that be a little easier to solve? And then how many blocks do we have going in the other direction? How many were in each? There were 8, right? 1, 2, 3, 4, 5, 6, 7. There were 8 of them. So I have now 3 with 8. So now I have 3, 6, 9, 12, 15, 18, 21, 24. So there are 24 blocks actually in both smaller arrays. So why would we need to add the products of the 2 smaller arrays? Why are we going to add 24 plus 24? Well, we want to know the number of blocks in the whole neighborhood, not just in half of the neighborhood. So that's why we need to add them together, because we want to know the total number of blocks in the whole neighborhood. Oops, sorry. It's my book here. We want to know the total number of blocks in the whole neighborhood. We don't just want to know half of it. We want to know the whole neighborhood. So that's why we broke it apart. And then we would need to put them back together. So I wanted to show you this vocabulary. So what we are doing when we break these apart, we are using the distributive property. And the distributive property states that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. So what we did here, right, when we did 4 times 5 is 20, is exactly the same thing as breaking apart our 5 to a 3 and a 4, or a 3 and a 2, still multiplying it by 4, and then taking those 2 answers and adding them together. That's all the distributive property is telling you. These 2 are the same exact thing. It's okay to break apart one of the numbers, multiply it by the other number, and then add those 2 answers together, add those 2 products together. and then you're going to get the same answer. And we could see that here in the example they gave us. So for example, if you have 5 times 7, if I break apart my 7 and make it a 3 plus a 4, right? If I have a 7, I know that a 7 is the same as a 3 plus a 4. And then I take that 3 plus my 4 and I multiply each of these digits by 5, because 5 is something I can do fairly easily, right? 5 is something I can count by very easier. So 3 times 5, 4 times 5, and then I'm going to need to add them both together. So 3 times 5 is 15. 5 times 4 is 20. When I add them both together, I get 35. So 5 times 7 equals 35, which is the same as breaking these apart. Okay? So now broke apart our array vertically to show 6 rows of 5 blocks and 6 rows of 3 blocks. What equations could we write for Nell's array? Well, she broke it to show 6 rows of 5 blocks. So we could multiply 6 times 5 equals, what is 6 times 5? 6 times 5 equals, if we count by 5, 6 times 5, 10, 15, 20, 25, 30. And then she also broke it apart to be 6 rows of 3 blocks. So 6 times 3 equals, we've got 6, 12, 18. 6 times 3 equals 18. Then I need to take both of my answers and I'm going to add them together. 30 plus 18, if I need to write it off to the side to put them on top of each other, I can. 0 plus 8 is 8. 3 plus 1 is 4. So 48. So how many blocks are in Nell's neighborhood? There are 48 blocks. So Nell's neighborhood has 48 blocks, which is right? If we remember, we said we split this in half. So 24 blocks were just in one side. If I were to take my 24, oops, that's not a very good 2. 24 plus 24, 4 plus 4 is 8, 2 plus 2 is 4. I got the same answer, didn't I? She just broke it up in a different way than we did. We broke it up in 3 times 8, 2 times. We did 3 times 8 twice, which was 24. She broke it up 6 times 5 and 6 times 3. But notice how we got the same answer. She took her 8 and broke it up into a 5 and a 3. We broke up the 6 into 2 3s. See how we can do that? We can just take the one that makes the most sense to us. Okay? All right, let's move on to number 2. So here is a map of Jody's village, and it shows that there are 4 rows with 9 blocks in each row. How many blocks are there? How can you use an array and the distributive property to help solve the problem? Well, let's first see what information we know. We know that there are 4 rows with 9 blocks in each row. And when we're all said and done, we want to know how many blocks there are. And how are we going to do that? We're going to use the distributive property. So let's follow these steps that it gives us down here. First, we need to draw a vertical line. So a vertical line is one that goes up and down. Vertical goes up and down. Horizontal goes side to side. So we're going to draw a vertical line to break apart the array into 2 smaller arrays for facts that we know. So I think we're going to draw the vertical line. So we're breaking apart a 9. So we want to break apart the 9. So let's break apart the 9 by, let's do it right here. So we're going to have 1, 2, 3, 4 blocks on one side and we're going to have 1, 2, 3, 4, 5 blocks on the other side. So we've got 5 blocks here, and we have 4 blocks here, and then we have 4 rows in each array. So when we broke apart our factor 9, we broke apart our factor 9 in a group of 4 and a group of 5, right? So over here, our 4 times 9 is going to be the same as 4 times a 4 plus a 5, because those are the two. That's how we broke apart our 9. So now I'm going to need to multiply each of those numbers by 4. So 4 times 4, and when I'm all done, I'm going to add it to 4 times 5. So I need to take my 4 and I need to multiply it by 4, and I also need to multiply it by a 5. So what is 4 times 4? Well, let's count by 4s, right? So we've got 4, oops, I'm going to use this to help me, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4, 8, 12, 16. So 4 times 4 equals 16. And 4 times 5. 4, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 4, 8, 12, 16, 20. So 4 times 5 equals 20. So when I add my 16 plus my 20, 6 plus 0 equals 6. 1 plus 2 equals 3. So that means that 4 times 9 equals 36. So there are 36, and our label is blocks. 36 blocks in Jody's village. Okay? All right. Now we're going to check for some understanding. So we have, I'm just going to move that a little closer so we can see it. We have a map of Transtown, and it shows 5 rows with 4 blocks in each row. How many blocks are in Transtown? Well, Transtown has 5 rows and 4 blocks in each row. So 5 rows times 4 blocks in each row would be our problem to solve, right? 5 times 4, that would be our array. Well, 5 times 4, I don't need to break this one apart because I can count by 5s 4 times, right? 5, 10, 15, 20. So 5 times 4 is 20, and he has 20 blocks in his town. Okay? So now we're to the point where it's the on your own section. And remember, if you want to pause the video right here and try this independently, you are more than welcome to. Or if you want to stick with me, that works too. You can always do this together. But if you do pause it, make sure you come back and check your answers and make sure they are correct. Alrighty, so we've got an array here, and we've got a kitchen counter, and it has 4 rows of tiles with 7 tiles in each row. How many tiles are on the counter? Well, let's break this one apart. What do we think? Let's draw a vertical line. So we know we have 4 rows of tiles, and there are 7 tiles in each row. So our problem is 4 times 7, right? But I want to break apart my 7. I want to make this so it's a little easier for me to solve. So I'm going to break apart my 7 by drawing a line right here. I'm going to draw a vertical line right here. So now my array, I've got 4 rows with 3 in each row for this part of my array. And then on this side, I still have my 4 rows, and now I have 4 tiles in each row. So I need to solve 4 times 3, and then I also need to solve 4 times 4. Well, let's look. 4 times 3, we have 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 4, 8, 12. So 4 times 3 equals 12. Over here, we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 4 times 4 is 4, 8, 12, 16. So that's one side of my array, and then 16 is, I've got 12 on one side and 16 on the other. So I'm going to take these and add them together to figure out what 4 times 17 is. Or 7, I apologize. So 12 plus 16, 6 plus 2 is 8, 1 plus 1 is 2. So 4 times 7 is 28. So there are 28 tiles on the counter. Alrighty, number 3. A box has 8 gemstones in each row. There are 5 rows. How many gemstones are in the box? So we have 8 gemstones in each row. And there are 5 rows. So what is our multiplication problem we are going to be solving for this one? We are going to be solving 5 times 8. This one I don't need to break apart. This one I should be able to solve because I should be able to count by 5s, right? So 5, 10, 15, 20, 25, 30, 35, 40. If I count by 5s, I get 40. So there are 40 gemstones. 40 gemstones. Okay, now we are going to use these arrays and we're going to show how we can multiply using the distributive property. Okay? So, this problem, we can see we have 5 rows. 1, 2, 3, 4, 5 rows. And then there are 7 in each row. 1, 2, 3, 4, 5, 6, 7. So we need to break apart our 7 into 2 numbers that will be easy for us to multiply by 5. I think I'm going to draw my vertical line right here. Okay? So now, on this side of my problem, I have 2 in each row. And on this side of my problem, I have 1, 2, 3, 4, 5 in each row. And there are 5 rows. So I broke apart my 7 and I made it a 2 and a 5. So I'm going to write 2 and 5 down here. So remember, first I need to multiply my 5 times my 2. And then when I'm done doing that, I'm going to multiply my 5 times my 5. And then I'm going to take both of those answers and add them together. Well, 5 times 2, we have 5, 10. 5 times 2 is 10, because that's 2 5s. Remember, 2 5s is 10. And then we have 5 times 5. 5, 10, 15, 20, 25. I'm counting by 5s. There are 25. So when I add 25 to 10, 5 plus 0 is 5. 2 plus 1 is 3. So 5 times 7 equals 35. Good job. All right, and our last one for this lesson, we have this long array here, and it's 3 rows with 9 in each row. We can see our 3 rows, and there are 9 in each row. Right? There's 9 down through here. So I am going to draw a vertical line again. This time I'm going to draw my vertical line over here. So I have 3 rows, and this part of my array has 1, 2, 3, 4 in each row. I still have 3 rows, and this part of my array has 1, 2, 3, 4, 5 in each row. So I broke apart my 9, and I broke it apart to equal a 4 and a 5. 4 plus 5 equals 9. So I'm going to be putting my 4 here and my 5 here because I know that 4 plus 5 equals 9. I broke apart my 9. I broke it apart. I expanded it out. So now I'm going to multiply each piece. 3 times 4. And then I'm going to multiply 3 times 5. 3 times 4 and 3 times 5. 3 times 4. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 6, 9, 12. 3 times 4 is 12. And then 3 times 5. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3, 6, 9, 12, 15. So now I'm going to add 12 plus 15. 5 plus 2 is 7. 1 plus 1 is 2. So 3 times 9 equals 27. Alrighty. So when you are finished doing this lesson, I want you to get your black and white worksheet that is stapled to this lesson, and you're going to do the front and the back of that, and then I'm going to need you to forward me a picture, or I know, Trevor, you've been bringing them into school, and Emma, your mom's been sending me the pictures, so those are both the perfect ways to get them to me, so that way I can see how you did. All right, I hope you have a great rest of your day, and I will see you soon. Bye, guys.